Okay, in this lesson, we're going to start talking about the unit circle, and we're going to use this unit circle combined with actually previous lessons to find sine, cosine, and tangent of angles of rotation. Now, let's begin discussing what we actually mean by a unit circle. Now, in math, the word unit, such as when we're talking about a unit rate, the word unit actually means one. And the reason we call this a unit circle, it says a unit circle is a circle that has a radius of 1 unit. So the distance from the center to the outside of the circle, the radius will be 1. So keep that in mind. So I told you we're going to combine actually a couple of previous lessons here. And just a quick reminder, when you have a point that's on the terminal side of some angle, we can find the sine, cosine, and tangent by doing this. The sine is actually from the previous lesson. The sine of an angle is actually equal to y over r when x and y is the actual point and the r is the distance from the center or the radius. And then our tangent was y over x. However, since we're talking about points today that lie on a unit circle, again, the distance from here to here for every one of these points, they're going to have a distance of 1. So therefore, on each of these, what we can actually do, since the radius is 1, we can replace r with 1. So therefore, the sine of theta won't be y over r anymore, but it will actually just be y. And the same thing with the cosine, won't be x over 1 anymore, it'll just be x. Let me go ahead and read the rest of this up here again. Because the value of r is 1 for each point xy, on this circle, the sine, the cosine, and the tangent values are defined in this way. Again, the sine is now y, the cosine is now x, and the tangent is still y over x since it doesn't involve r. So therefore, the coordinates of any points, so this is the most important part of this today, every point on this unit circle, and again, it has to be on the unit circle for this to work, every point on this unit circle can now be written as this. Since the x value is now the cosine, our cosine is x and the sine is y, we can now write every point as cosine theta, comma, sine theta, to where, again, the cosine is our x value and the sine is our y value. So every point on this unit circle, the x value represents the cosine, the y value represents the sine. And again, the tangent would be the y over x or the sine over cosine. Okay, and that leads us to the next section, and that is special angles. And I'm going to go ahead and talk about quadrantal angles. But it says the following angles are used frequently with the unit circle. And notice that 30, 45, and 60 are on here. We'll go back and revisit those in a second. Then you have these other angles that are very common. Because the terminal side of 0, 90, 180, and 270, and that actually involves 360 as well, they left out, lie on the axes. They are called quadrantal angles. And notice it does say memorize these values. We will be memorizing these. So what we're doing here, we're going to start with these quadrantal angles, is just, again, keep in mind that the sine and cosine of these points are simply the y values and the x values of those points. And I do want to remind you that this is a unit circle, so the distance from here to here is 1. So we can very easily find those points. So let's start with 0, 360, and let's fill in this chart real quick. So right here at 0, 360, this point, the distance from here to here being 1, so therefore that point is going to be 1, 0. When you're at 90 degrees, that point, again, the distance from here to here is 1. So therefore, this point, we don't move left or right any, we simply move up 1. So that point at 90 degrees is going to be 0, 1. So let's skip down and put 0, 1 at 90 degrees. At 180, let me zoom back in. At 180, now it's going to be very similar, but you're going left 1. So at 180, we're going to have a point of, let me zoom out so we can see the 180. At 180, we're going to have a point of -1, 0. And then at 270, you can do the exact same thing. We're going to have a point of 0, -1. Now, what does this mean to us? Again, each of these points represents a cosine value and a sine value of that angle. So what we can do, the cosine therefore would be 1, the sine would be 0. At 90 degrees, again, we have sine and then cosine. So the sine would be 1, the cosine would be 0. Can't get it to line up here. We would have 0, -1 at 180, and -1, 0 at 270. Now let's extend this further and talk about the tangent values. And again, reminder that tangent from our chart above, tangent is equal to y over x. And we can use these values, or we can use sine over cosine, since sine is y and cosine is x. So tangent would be 0 over 1, or 0. Tangent here would be, you got to be careful, 1 over 0. You cannot divide by 0, so that would be an undefined tangent. Here we're going to have 0 over -1, which is 0. Again, it's y over x. And this is our x and y values here, or excuse me, this is our y then x values. And then the next one is going to be -1 over 0, which is again an undefined tangent value. We cannot divide by 0. One other thing they ask us to do here is we have degree measures and radian measures. So let's go ahead, and we know what 0 degrees is. That's 0 radians. And then 360 from previous lessons, that was 2 pi. Since pi is 180 degrees, 180 divided by 2 would give me my 90. Again, pi is 180, so 180 would be pi. And then 270 is actually 3 90s. So that'd be 3 pi over 2. Now, for the next part, we still have gaps in our chart that we've not filled out, but I do want to remind you of something. I want to go back to 12.1 where we discussed this. And we've already actually found these values. Let me minimize that. We found the sine of 45, the cosine of 45, the tangent of 45, and the same thing for 30 and 60. So I'm simply going to take these values and go back and fill our chart in. And there those values are. So one other thing to realize, though, again, let's connect these two lessons, is that these points represent more than just the sine and cosine. These actual values are the x values and the y values of the points that correspond on this unit circle. So this point right here at 30 degrees, where 30 degrees crosses this unit circle right here, the x value at this point, which is, we can go down here to 30 degrees, the x value at this point is going to be the same thing as the cosine value at that point. The y value is going to be the same thing as the sine value. So we can, over here where it says xy, the x value is going to be √3 over 2. The y value is going to be 1/2 because, again, that corresponds with the cosine and the sine value. So that's that actual point where it crosses. And we can do the same thing for 45. It's going to be √2 over 2, comma, √2 over 2. At 60 degrees, our x value is going to be 1/2 because the cosine value is 1/2, and the y value is going to be √3 over 2. Now, the last thing we need to do is to actually turn these things into radians. And again, I remind you that pi is 180 degrees. So in order to turn 30 degrees into radians, all I have to do is take my 180 and divide by 6. That'd be 30 degrees. 45 is pi divided by 4, would give you 45 degrees. And 180 divided by 3, that would be your 60 degrees. Okay, the next part of the lesson actually wants us to take those values and label our unit circle. We've got a full-page unit circle, and we're going to take those and translate them over into our unit circle. It says use these angles as reference angles for the remaining angles around the circle, and then adjust your coordinates by looking at which quadrant the point is located in. We'll talk about that as we go. Okay, here's my unit circle page, and what I'm going to do, I'm going to start in this first quadrant, and I'm going to go ahead and label everything that we were given from the table. And there we go. I've got all those labeled. And again, I can't say this enough. Remember, as we label these, the x value of each of these points correspond with the cosine value of that angle. So the cosine of 0 is 1. The cosine of 30 right here is 1/2. The sine values are related to the y values. The sine of 45 is root 2 over 2. The sine of 60 is root 3 over 2, and so on and so forth. And notice what I've done is I went ahead and labeled 180 with its cosine and sine values. I've labeled 270 with its cosine and sine values. So if I were to ask you, what's the sine of 270 degrees, you would tell me -1. Now, what we're going to do is actually relate this with something else that we've discussed in a previous lesson, and that being a reference angle. Now, let me show you what reference angles has to do with the unit circle and why we actually did reference angles. If you were to take 30 degrees, and every angle here that has a reference angle of 30, that'd be 150, has a reference angle of 30 because it's 30 degrees from the x-axis. 210 has a reference angle of 130, and 330 also has a reference angle of 30. Notice these points. If you go to 30 degrees, in order to get there, you went right. Excuse me, I actually labeled that wrong. Let me relabel it. There we go, that looks better. So in order to get to 30 degrees, you would go right, root 3 over 2, and you'd go up 1/2. Well, to get to this 150 over here, you're going to go left the exact same amount, because when you're dealing with a unit circle or any circle, there's tons of symmetry. So this point would be symmetrical with this point. Across the x-axis, it would also be symmetrical down here with this point. This point is symmetrical over here with this point. All of these points have symmetry. So in order to get to this point, if you go right root 3 over 2 and up 1/2, then to get this to this point over here at 150, you would go left root 3 over 2 and then up 1/2. To get to this point at 210, you'd go left the exact same amount, root 3 over 2, and then you go down 1/2. Then to get to this point over here at 330, again, you do the same thing you did up here at 30. You went right root 3 over 2, but you would go down, or a -1/2. So that is what reference angles has to do with the unit circle. Is if two angles have the same reference angle, they'll actually have the exact same cosine and sine values. The only difference is sometimes they'll be positive, sometimes they'll be negative. And we'll talk about in just a second how to determine if they're positive or negative. And you probably already know that. So let's talk about 45 degrees, and let me mark all four of those reference angles now. And there those are. And now let's talk about the cosine and sine of that 45. So at 45, you went right root 2 over 2 and up root 2 over 2. So to get over here to 135, you're going to go left root 2 over 2 and up root 2 over 2. So down here at 225, left, move that off the screen. It'll be left and down. And over here at 315 will be right and down. Now let's do our last set of reference angles. Let me go ahead and mark those. And there you have all your 60-degree reference angles. So let's go ahead and do the exact same thing for those values. 1/2 root 3 over 2 is your cosine and sine of 60. So this would be left 1/2 and up root 3 over 2. Down here will be left 1/2 and down root 3 over 2. This will be right 1/2 and also down root 3 over 2. So now let's look at our chart down here at the bottom. So again, the trig values, the sine value will always be the y value, the cosine will be the x, and the tangent will be y over x. And I'm going to go ahead and throw this in. From previous lessons, you talk about slope when you're discussing lines. And if you'll think about the slope of a line, like if you'll look at this 60-degree line, the actual slope of that line is the rise over the run. And when you're talking about this point right here, the y over x would actually correspond with the rise over run. So I'm going to throw it in that the tangent's actually equal to the slope as well. Now let's talk about these signs, the summary of the signs in the quadrants. So in quadrant one, sine, cosine, and tangent, if we go up to quadrant one, notice the sine, the cosine, and the tangent. If you were to check from before, it'd be positive over positive. All of those signs are actually positive because x is positive, y is positive, so therefore y over x would be positive as well. In quadrant two over here, your x values are negative, your y values are positive. So therefore, your cosine values are negative since that's the x. The sine values will be positive. And since tangent is y over x, a positive divided by a negative would be a negative. In quadrant three down here, notice that x and y are both negative. Now here's something to think about. Since tangent is y over x, that'll be a negative over a negative. Your tangent is actually positive in that third quadrant. And in the fourth quadrant, your x values are positive, your y values are negative. So therefore, cosine will be positive, sine will be negative, tangent would be negative since you have a negative divided by a positive. And just to better remember that, let's go ahead and it's talking about, again, signs of the trig functions. And you can go back and look at your chart if you'd like. But in quadrant one, everything was positive. In quadrant two, sine was positive, which I'm going to go ahead and put this on there. Since sine is positive, if you were to flip sine, you get cosecant, if you remember from previous lessons. So since sine's positive, cosecant would also be positive. In quadrant three, the only thing that was positive was tangent. So therefore, its flip or cotangent would also be positive. And then in quadrant four, cosine was positive. So therefore, its reciprocal or secant would be positive. Now, the way we can remember this, another mnemonic device that we can actually use to remember what's positive and where it's positive. In the first quadrant, everything was positive. In the second quadrant, sine was positive. Third was tangent. And fourth was cosine. We can remember this with the mnemonic device. All students take calculus. Notice all students take calculus. If we just take the first letters from each of those, it'll tell us what'll be positive and in which quadrant. So let's work some problems now using that. If tangent is greater than zero, now this greater than zero, just understand that simply means if something's greater than zero, it means it's positive. If tangent is greater than zero, which quadrants could the terminal side lie in? So if tangent is positive, it could be here where everything's positive or here where only tangent's positive. So that'd be either in quadrant one or quadrant three. If secant is negative, secant's less than zero. Now, when we're talking about secant, we're also talking about cosine. So where is cosine negative? So cosine is positive here and here. So if it's negative, we would have to be either in the second quadrant or the third quadrant. If sine is greater than zero, which quadrants could it be in? And that would be where everything's positive or sine is positive. So that'd be either in one or two. And then number four says if cosine is negative, let's stop right there for a second. Let me go ahead and clean this up. There we go. So if cosine is negative, so cosine is positive here and here in the first and fourth. So if it's negative, we're either here or here because, again, cosine is x. And when you go to the left, that's where x values are negative. So therefore, if cosine is negative and cotangent is positive, which if cotangent, then tangent, because they're just reciprocals. So we're wanting to know where cosine is negative and tangent or cotangent is positive. Cotangent and tangent are positive here. So therefore, this quadrant, which would be quadrant three, would be where that's true. Cosine is negative and tangent or cotangent would be positive. Okay, the last section we're going to do in this actual lesson, it says using reference angles to find the trig values. Now, this is extremely important, and it goes along with what I told you a while ago, that we can actually use the reference angles to find the sine, cosine, and tangent as needed. So here's your steps. We find the measure of the reference angle. We identify the trig function for the reference angle. and then we're going to adjust the sign as needed. That's all we've got to do. So it says give the exact values. We're not just typing these in our calculator and finding them. We're going to actually use reference angles to find these. So the sine of 150, the first thing we need to do is identify what is our reference angle. So 150, this is 90, and 180. So 150 is somewhere in that second quadrant. So let me kind of just draw a line. It's somewhere right in there. Okay. Our reference angle is how far are we from the x-axis, which is 180. So we are 30 degrees away. So what I like to do is just mark this out and put 30 degrees. Now, before I did that, now I like to do it in a different order than what they do. Let's determine whether our answer here is going to be positive or negative. The way we're going to do that is all students take calculus. And since we are in the second quadrant, notice it's S. That tells us that sine is positive there. Another way we could do that is sine is a y value on our unit circle. So y is positive in the second quadrant. So I'm going to go ahead and put a plus sign. We don't have to. I'm going to put a plus sign just to show you, hey, I checked that, and that's what it's going to be. Now, once you do that, all you have to do is find what is the sine of 30. The sine of 30 is equal to 1/2. So therefore, on number 5, we get positive 1/2. Now, in order to work that problem, I needed to know what the sine of 30 was. And I just want to come over here to the side, and I do want to write these out. There's a pattern when we're dealing with sine and cosine. 0, 1/2, root 2 over 2, root 3 over 2, and 1. If we're dealing with sine values, a sine of, and again, 0, there's certain angles, again, that we're needing to memorize here. 0, 30, 45, 60, and 90. When I'm dealing with sine, I'm simply doing it in order. The sine of 0 is 0. The sine of 30 is 1/2. Sine of 45 is root 2 over 2, and so on and so forth. If I'm dealing with cosine, if you haven't noticed yet, it's the exact same values, just backwards. The cosine of 0 is 1. The cosine of 30 is root 3 over 2. Cosine of 45 is the same. Cosine of 60 is 1/2. Cosine of 90 is 0. So therefore, we can use those patterns in order to find the sine and cosine of these angles. Now, number 6, we're dealing with a tangent, though. So therefore, the tangent of 300, I'm going to draw it. This is 270. This is 360. So 300 somewhere in here. And again, our reference angle that we're looking for is how far are we from the x-axis, and that would be an angle of 60 degrees. Now, before we go ahead and do the tangent of 60, though, let's go ahead and determine, is it positive or negative? We have all students take calculus. The only thing positive is cosine, so therefore tangent will be negative. Our reference angle is 60, so we can now mark this out and put 60. The tangent of 60 is equal to root 3, so therefore our answer is going to be negative root 3. And again, the tangent of 60, for now, you can go back and look at your chart, and you can see that that is equal to root 3. Number 7. Step number 1, 225. Let's draw it. This is 90, 180, 270, so it's somewhere here. Let's determine positive or negative. That's going to be all students take calculus. The only thing positive in the third quadrant is tangent, so therefore our answer will be negative. To look for our reference angle, again, this is 180. We're asking ourselves how far past 180 are we, and we can simply subtract it, and we can find out that we're 45 degrees as our reference, and the cosine of 45 now is root 2 over 2, and we're done. Number 8. Now we're dealing with the cotangents, and we'll deal with cosecants and secants as well. But what we're going to do is, in order to find the cotangent, I'm going to come over here and do the tangent of 315. Okay, let's start out with the tangent of 315, and I'll show you why in just a second. So we are going to simply draw 315. This is 270 and 360, so we're somewhere down here. It doesn't matter how exact you are as long as you're in the right quadrant. All students take calculus. Cosine is positive, so therefore tangent will be negative. The only thing that's positive here is cosine. We're now looking for a reference angle. How far are we from the x-axis? Let's mark that out. This is 360, so we're 45 degrees away from 360 if you subtract that off. The tangent of 45 is 1. Since the tangent of 40 or 315, we just found out is -1, in order to find the cotangent, we just flip it. And when you flip -1/1, you get 1/-1, which is still -1. That's the cotangent of 315. Number 9, the tan of 240. So let's draw again 240. This is 180 and 270, so 240 is somewhere in that third quadrant. So here we go. There's about 240. All students take calculus. Tangent is actually positive there, so let's go ahead and put our plus sign. So just to remind ourselves that we did check it. We now need a reference angle. We find out how far are we from the x-axis. This x-axis here is 180. When you take that away from the 240, that shows you that you are 60 degrees away. So now we're looking for the tan of 60, which we know is √3. So positive √3 is your answer. Number 10, the secant of 300. Well, since we're dealing with secant, let's talk about his brother. Let's find the cosine of 300 first, and then we'll just flip it. So 300, let's go ahead and sketch that. This is 270 and 360, so 300 is somewhere in this fourth quadrant. All students take calculus, so that'd be a C, so that's telling me that cosine is positive. Our reference angle is how far are we from here. This is 360 degrees. Just a reminder, this is 0 and 360, and this is 180. That's what we use to find our reference angles. So we are, if you subtract off, we are 60 degrees away. So we're looking for the cosine of 60, which is 1/2. So therefore, the cosine of 300 was positive 1/2. In order to find the secant of 300, you simply flip it. That'd be positive 2/1 or just 2. Okay, number 11, now we're dealing with radian measures. And just a quick reminder, in order to switch from radians to degrees, if it has this pi in it, it's really easy. That pi is equal to 180. When you take the 180 and divide it by 6, you get 30. When you take that 30 and multiply it by 11, you get 330. So we're actually finding the cosine of 330 here is what we're looking for. So let's take and graph it first. 270 and 360, so we're somewhere here. All students take calculus. Cosine is going to be a positive value. Our reference angle right here is, since this is 360, we are 30 degrees away, so let's mark it out and put 30. The cosine of 30 degrees is √3/2. There's your answer, positive √3/2. The next one is about as tricky as you get because you do have to deal with radians and you're dealing with a reciprocal here. So in order to find cosecant, we're going to find sine instead. And I'm going to go ahead and switch this to degree measures just because we're more comfortable with it. This is 180. 180 divided by 4 is 45. If you multiply that by 7, it gives you 315 degrees. So we're looking for the sine of 315, then we're going to flip it to find our cosecant. So 315, and you'll get to where you can do this part in your head. 315 is in the fourth quadrant between 270 and 360. All students take calculus. So sine, since cosine is positive, and that's the only thing positive, sine will be negative. 315 is 45 degrees away from 360. So let's go ahead and mark that out and use 45 instead. And the sine of 45 is √2/2. Now, in order to do the cosecant of that 315, we're going to flip that. That'd be -2/√2. Since we have a root on bottom, and this is what's making it a little bit trickier, we're going to have to rationalize that. If you don't remember how to rationalize, we're going to multiply top and bottom by √2. So on top, you now have -2/√2. On bottom, √2 times √2 is 2. The 2's cancel and leaves me with simply -√2 as an answer. Number 13. The sine of 4 pi over 3, again 180. 180 divided by 3 is 60. 4 times 60 is, we're looking for the sine 240 degrees here. Let's sketch it. 180 and 270, between it is where we're located. All students take calculus. So since tangent's the only thing positive, sine will be negative. This is 180. And we're at 240, so we're looking for this reference angle between 180 and 240, which is a 60-degree angle. The sine of 60 is root 3 over 2. So therefore, the sine of 240 degrees is negative root 3 over 2. Okay, on to number 14. Got three more. The tangent of 3 pi over 4, 180. 180 divided by 4 is 45 times 3 is 135. So we're doing the tan of 135 degrees here. Sketch it. 135 is going to be between 90 and 180. So it's in the second quadrant. All students take calculus. Sine's the only thing positive, so therefore tangent is negative. Find out how far we are from 180. We mark it out. Subtract the 2 gives me a 45-degree angle. The tangent of 45 is 1. So therefore the tan of 135 would be negative 1. Number 15. 180 divided by 6 is 30, times 7 is 210. So on this one, we're looking for the sine of 210 degrees. Sketching it, I believe that puts us in the third quadrant between 180 and 270. All students take calculus, so therefore tangent's the only thing positive, so sine is negative. 210 is how far from 180? Mark it out. That'd be a 30-degree angle as your reference angle. The sine of 30 is a half, so therefore the sine of 7 pi over 6 is negative 1/2. And the last one, the secant of pi over 2. Again, 180 divided by 2 is 90. What we're actually looking for here is the secant of 90 degrees. In order to find the secant of 90, we must first use cosine. So we're looking for the cosine of 90, and then we're going to reciprocate it. Now, 90, there's something special about it. 90 is one of those quadrantal angles. With quadrantal angles, you really don't have to fool a lot with reference angles and all that, because you are simply, if you remember what sine and cosine are, it's the x and y values of that point on the unit circle. This point right here that I just labeled on the unit circle, the radius is 1, so therefore this point would be 0, 1. So therefore that represents the cosine and the sine values of 90 degrees. So the cosine of 90 degrees, the cosine's that x value right there is simply 0. So what we've got to do in order to find secant, we've got to reciprocate 0. When you flip 0 over 1, you get 1 over 0, which is actually undefined. So therefore, even though we can find cosine, which is 0, when we try to flip it, we get 1 over 0, which is undefined. Secant does not have a value. It has an undefined value at 90 degrees, and that's the last problem.